Okay, so in this video, I want to discuss a few questions, a few past year questions on Kirchhoff's law, however it's pronounced. So let's get into it. Let's look at the first question. This is the first question. The figure shows a circuit that consists of 3 batteries and 3 resistors. Okay, calculate current I2. So we're looking for current I2. First things first, when we apply KVL and KCL, right, we want to look for junctions, right? So KCL requires junction, or what we call nodes. Okay, so let's focus on this one. I have I1 going in and I2 going in as well, and then I3 is leaving it, right? So I3. So then when I apply my Kirchhoff's current law, so I in equals to I out. What goes in must come out. So then I will have I1 plus I2 is equals to I3. So this is my first equation. My second equation, let's use a different color. My second equation, I will have to apply that's a bit too big. I will have to apply Kirchhoff's voltage law, which talks about loops. Okay, so to make it easier, I will label this as A, B, C, D, E, and F. I want to look at loops. I will say which loop am I looking at. I'll write it down as well. Okay, so when I want to apply KVL, right, let's choose a loop. Now, one of the things that one of the tips that you can use is actually use loops that is sort of, you don't have to flip the current. So for example, if I were to choose, let's see, I can choose B, E, D, C, B. So that's a loop. So it goes this way. I don't need to flip I2 or I3. So I2 and I3, I'll just maintain it. Now, we have 2 parts. We have voltage rise, things that rise the voltages, and things that drops the voltages. All right. Okay. So let's look at the battery first things first. The first battery that we want to look at is the 5 volts. I have positive and negative, and it's pushing in the same direction as I2, and therefore it rises up the voltage. So it's going to be 5 volts here. And then I want to look at the 10 volts. The 10 volts, we will have the positive terminal here and negative terminal here. It's pushing the same direction as I3, so then we can classify it as rise in voltage. So we'll have 10 here. Okay, and then of course the resistors are just drop voltages. So I will have I2 times 5, then I have I3 times 3. So then if I were to combine these 2 parts, I will have 15 equals to 5I2 plus 3I3. Okay, this is when I apply KVL for the first time. Okay, so this is me applying KVL for the first time. Let's do it the second time, right, using a different loop, right? So KVL second loop. Okay, so again, I don't want to flip any currents, so the easiest way for me to do that is just to use the loop of A, F, E, D, C. Sorry, that's not right. The easiest for me to do that, I'm just going to change the color to be darker. There we go. A, F, E, A, F, A, F. I want to ignore the junction. So A, F, D, C, A. So this is my loop. So it goes all around like that. Okay. And then I'm going to consider the battery again. So let's write down V rise. Okay, so the battery has positive and negative terminal. Positive and negative terminal. so it's the same direction as I, so the 12 volts is considered as a rise in voltages. Okay, and then let's look at the 10 volts. Again, the 10 volts is same direction as I3, so then I will have rise in voltages again. So now we look at the resistors that are involved. Two resistors are involved, the 3 ohm and the 4 ohms. So then I will have 3I3 plus 4I1. Okay, if I combine this, I will have 22 equals to 3I3 plus 4I1. Okay, so we have our three equations that we need. Here's our second equation, and then here's our third equation. Okay, I'm just going to quickly write it down here because makes things easier. So I have I1 plus I2 equals to I3. Then I have 15 equals to 5I2 plus 3I3. Then I have 22 equals to 3I3 plus 4I1. So these are our three equations that we're going to use. Okay, so one of the things that we want to do, because we want to focus on I2, okay, what I can do is I can substitute I3 into the last two equations. That's what I can do, and then I can sort it out by removing I1. Okay, so what I'm going to do is I'm going to put equation 1 into 2 and 3. 1 into 2, I want to remove I3. I will have 15 equals to 5I2 plus 3I1 plus I2. Then what I'm going to have is 15 equals to 5 plus 3 is 8I2 plus 3I1. This is equation number 4. I do the same thing again on this side. I will have 1 into 3. I will have 22 equals to 4I1 plus 3I1 plus I2. I'm left with 22 equals to 7I1 plus 3I2. Okay, so once we've achieved that, this is equation 5, I can solve equation 4 and 5. And take equation 4 and multiply it by 7 over 3. So then I have 15 times 7 over 3 equals to 8 times 7 over 3 I2 plus 7 over 3 times 3 I1. This just gives me 7. And if you've noticed, if I rewrite equation 5, I will have 3I2 plus 7I1. So this is equation 6. All I need to do now is minus them out. Okay, so I can have equation 6 minus equation 5. All right, so then I will have 35 minus 22 equals to 56 over 3 minus 3 I2, and then plus 0 I1. So then my I2 is equal to, so 35 minus 22 is 13 over 56 over 3 minus 3. which should give me an answer of 33 over 47, which is approximately 0.829 amps. Okay, and that would be my final answer. That is the value for I2. Okay, all right, let's look at the next video. Okay, so let's look at the second question. All right, the figure shows a circuit consisting of 5 resistors, okay, a voltmeter and an ammeter connected to a battery. The reading of the ammeter is 1.25 amps. Determine the voltmeter reading. So from the question alone, I can see that the current through here is 1.25 amps. That makes it easy for us to find the voltage across R2, which is going to be the same as the voltage across R3 and the voltage across R4 plus R5. All right, and this is going to be IR, which is just 1.25 multiply 25, and this is going to give us a voltage of 31.25 volts. Okay, so the current across resistor 2 is 1.25 amps, and because R4 and R5 is effectively 25 ohm, this is going to be its current as well, so R4 plus R5. So really we're left with finding out what is the current through resistor R3. So if I know the value for the potential difference across R3, I can figure out its current, right? Because I know the resistance, that's for sure. So I can just substitute the values. I will have 31.25 equal to IR3 multiplied by 15. Okay, so then my IR3 is equal to 10.42 amps. Okay, so this is where we apply KCL, right? So if we have KCL just right here, and then we consider the junction at this point, you will have I1, I2, I3, which is just, let me just write that down. The current across R1 is equal to the current through R1 is equals to current through R2 plus the current through R4 plus R5 plus the current through R3. So that means it's going to be 1.25 amps plus 1.25 amps plus the 10.42 amps. Okay, so then I can multiply the whole thing. Let me just change colors at this point. I can multiply the whole thing by its resistance, so let's call it R1. I can multiply this whole thing by R1 to find the voltage. So here your R1 is 15, so thus your voltage across R1 is simply 68.7 volts, and that is my final answer. Okay, all right, moving on to the next question. Okay, moving on to the third question, which is from 2122 paper. Okay, so in this question we are asked to determine I1, I2 and I3. So we can start with just applying KCL, right? We can apply KCL, and what the equation that we find is that I1 is equals to I2 plus I3. That is generally our first step. Now we want to apply KVL. I will, as per usual, I will start labeling A, B, C, D, E, F. Right, It's easier that way. I will start to apply a KVL to, let's see, the easiest loop is just to have A, B, E, F, right? So A, B, E, F, where we have a battery. Our battery has a positive terminal here and a negative terminal there. And we can see that the current push by epsilon1 is the same direction as I1. So I can safely say that epsilon1 belongs to the V rise category. So epsilon1. And then the resistor belongs in the V drop value, which is just I2 times R1. So here we can quite easily see that epsilon1 is equals to I2 R1. And what this means is that 10 is equals to I2 times 30. So that means I2 is actually equal to 0.333 amps. Okay, so that's our first answer. Once we've done that, the next part that we can look at, right, is we can start to choose loops that has the least number of resistors and ones that we do not need to change its current if it's possible. So we can look at loop. So again, KVL, I will look at loop A, C, D, F. I will not consider E at all. E and B junctions, I will ignore it. So as before, I will have V rise to be equal to epsilon1, right? Because we've established that. But now we have to look at epsilon2. We have positive on this side, negative on this side. That means the current pushed by epsilon2 is against I3. So then our our epsilon2 will be on the side of V drop, which is going to be 5. And then how many resistors do we have? We have one resistor, R2, and the current going through it is I3. So that means, let me just erase that. I'm just gonna correct it. E epsilon2 plus I3 R2. That means epsilon1 is equals to epsilon2 plus I3 R2. So epsilon1 is 10, epsilon2 is 5 plus I3 times 20. Okay, so then I'm left with I3 equals to 10 minus 5 is 5, 5 over 20 is 0.25, so 0.25 amps. That is my I3. And then I can find I1 using I2 and I3. So I1 is equal to I2 plus I3, which is 0.33 plus 0.25. We find that I1 is simply 0.58 amps. And that is the answer for the third part, which is I1. Alright, so we always try to do the easiest ones first. So if I look at loop A, B, E, F, there's only one battery and one resistor. That's fairly easy to do. Okay, alright, so let's move on to the next question. Okay, so here's the last part. Let's just read the question at hand. The figure shows a circuit consisting of 2 batteries and 2 resistors. Calculate the value of I3 and R3. Alright, so first things first, let me just label it again. Different color. A, B, C, D, E, F. Okay, so if we consider the junction at C, right, we can apply KCL such that I will have epsilon I in, epsilon I in is equal to epsilon I out and my I in is I3, my I out is I2 plus I3. My in is I1, my out is I2 and I3. I know my I1 is 9, I know my I2 is 3, so that means I3 must be 6 amps. Okay, so now we want to look at R3, value of R3. I'll use a different color. Okay, so I want to look for R3, and if you look at the loop, the possible loops, I have option A, B, C, F, A. That's one option, but it doesn't go through R3. We want the ones that goes through R3. So the ones that goes through R3, one of it is F, C, D, E, right? But I have to flip the current. Best not to do that. So let's just do A, B, D, E. So I want to apply KVL to loop A, B, D, E, A. So it goes one whole round, and I can see that my battery has a positive terminal here, negative terminal here. It's going to push current in the same direction as I1. So then my V rise is going to be 18 volts, and then my V drop is just the one, which is I3R3. Okay, specifically, let me change that. I will have here as epsilon 1. So if I combine these two, I will get epsilon 1 equals to I3R3. Epsilon 1 is 18 volts. I3, we already established that I3 is 6 amps. It's going to be 6, and then R3. So that means my R3 is 3 ohm. And that solves that problem. Okay, thank you very much.